All right, so I want to do a couple of examples for conversions. At this point, hopefully you watched the introductory video on doing the factor label method. And so we're just going to do a couple more examples. So let's convert 106 micrometers to centimeters. And this is where you need to pause the video or pause the pencast if you're watching it and do this yourself. Do the calculation, see what you get. Okay, you pause it? Okay. Okay, you're back. How'd it go? All right, here's the deal. We need to memorize these metric prefixes. So we need to know that micro, so that's micro, and that's 10 to the minus sixth, right? And we need to know that C is centi, and that's 10 to the minus 2. Now, let's first set up our factors, our conversion factors, right? Now, you might think, well, I have to figure out how to get from micrometers to centimeters. I don't think that's a good idea. You can, that's the way I used to do it. But I think there's some pitfalls to doing that, right? It's a little harder to figure out. I mean, you can see 10 to the minus 6, 10 to the minus 2, it's going to be 10 to the fourth difference. But is that really the best way you want to do it in order to not make a goof, right? You don't want to make a goof. So you got to build things, build the practice that makes sure that you're not going to make any mistakes. You know, like labeling drugs and having the different dosages in the bottles being different color bottles so that you don't give the patient the wrong drug, which happens. So little things we want to build in practices to make sure we don't make any mistakes. So the factors, first, 1 micrometer is, so micro means 10 to the minus 6, so it's 10 to the minus 6 meters, okay? And we can, so I think it's always best to go to the base unit. Now I know we talked about an SI, you know, units, kilograms, the base unit. No, I'm talking about in the metric system, the one that doesn't have a prefix. Rather than going from micrometers to centimeters, let's go from micrometers to meters, then meters to centimeters. 2 steps and a little safer. So the factors that you would get from this equality, the conversion factors, would be 1 micrometer over 10 to the minus 6 meters. That's equal to 1. Or 10 to the minus 6 meters over 1 micrometer is also equal to 1. So those are our 2 conversion factors. And when if you're new to this and you're just starting this, or you need to certainly, you know, refresh your memory of it, you want to go ahead and write down these conversion factors when you start. After you kind of get the hang of this, you won't have to write it down. You'll have this, and you'll know that, well, however I need to use it will work. I can do meters over micrometers or micrometers over meters, and it'll work just fine. Okay, so I'll do that actually with the other one. So centi, now centimeter, we could write 1 centimeter is equal to 10 to the minus 2 meters, right? Because centi means 10 to the minus 2. Does that make sense? But if it's for me at least, and I don't know, maybe you're different, but for me at least, the ones that we're familiar with, so micrometer, not so much, right? We're not going to put a million in there. But centimeter, we can remember that the ones that we're familiar with a little differently, right? We know there's 100 years in a century, and so most people know or are more comfortable with saying, well, I know there's 100 centimeters in 1 meter. Now, you know, both of these things are true. They're equivalent. It's just a matter of what you're more comfortable with, right? You can use this one or you can use this one because they're the same thing, right? It's just the way that you remember it. Okay, so those we can use to make our conversion factors. So let's go. So the rule on factor label method is first write down the one that you're given. 160 micrometers. I'm sorry, 106 micrometers or micrometers, depending on how you want to say it. I don't actually know which is right. It was a micrometer caliper back when I was riding my dinosaur to class, but anyway, who knows? So start with the one you're given, and we want to work towards centimeters. So I'm going to go from micrometers to meters, and that means I want micrometers to cancel, so that unit is going to be in the denominator, and meters is going to be in the numerator, right? And then cancel out your units, and we're now in meters, so that's good. Then from this other conversion, we want to go from meters to our answer in centimeters. I'm going to use the one on the bottom. Either one would work. But so there's 100 centimeters in 1 meter. I want the meters to cancel, so I put that on the bottom. The unit we want is centimeters. That goes in the numerator. Cancel out your meters. And now we know, because we got centimeters, we know we did this right. And so we can do 106 times 10 to the minus 6 times 100 and figure that out. I should be able to do that in my head. So that'd be 10 to the minus 4th. Oh my, I'm nervous because what if I get it wrong? So would that be 1.06 times 10 to the, let's see, what would that be? Minus 2? I believe that's right. If I get this wrong, that would be awesome, because then you could post and say, Vit, you idiot, you got it wrong. But I'm going to check on my calculator, right? I've got a calculator here, so why not? So I'm going to take 106, and then I'm going to take it times 1e minus 6, use my scientific notation button so I don't have to worry about parentheses or anything, then times 100. Let's see what we got. Aha! It is right, because that would be 0.0106 centimeters. All right, good deal. That worked. So here's the other thing that I want to talk about. If you had an old, like me, high school chemistry teacher, there's a pretty good chance that you were taught this kind of hash method, right? And you would write your 106 micrometers here and go on through. That's the way I was taught back when I was riding my dinosaur to chemistry class in the whenever that was, long time ago. But I don't teach it that way, and I don't like it that way. It's the same exact thing. So if you learned it that way, you're comfortable with it, fantastic, no problem. But the reason I don't like doing the hashes is because it makes it seem like there's some kind of special math just for chemistry, right? These hashes, if this is just multiplying, right? Parentheses, multiplying it by a ratio, parentheses, multiplying it by a ratio. It's just regular math. There is no special math for chemistry. It's not some secret society, okay? So that's why I don't like the hashes, because I don't want you to think this is just chemistry. In fact, if you master this factor label method, you can solve, or at least what I found back 100 years ago when I took physics, you can solve most of your physics problems that way too. I mean, you got different, if you get the units right, you got an equation, whatever, it comes out, you're good to go. So it's a really powerful problem solving skill to be able to do that. And you want to work on being able to do this kind of conversion using the factor label method, because if we did the ratio method, we'd have to stop here, solve for the problem, rewrite it down here, and it just gets a little cumbersome when, like I said, when we're doing stoichiometry, when you might have 3, 4, 5 conversion steps between different chemicals, between different moles and grams and so on. So I would suggest using that. You get the units right, you're in good shape. I'm going to go ahead and on the same video, I haven't done this, but I want to have another example, and let's see, where you have more compound units. So let's do an example 2. See if I can find one. I kind of do this, I'm trying to do this as much as I can like I'm in class, which means it's not rehearsed, right? I go in and I explain to you and you work on examples. So let's say we have a cube, and that cube is 1 meter on each side. So it's just a block, 1 meter each side. And the question is, how many liters of water would this hold? In other words, what's the volume, right? And we need to know something about meters and liters in order to be able to do this, right? So the conversion factor that, or the definition that you'll be asked to know is that 1 milliliter is equal to 1 centimeter cubed, right? So length cubed is a volume. So 1 centimeter cubed is 1 milliliter. That's just the definition back and forth. And so if we want to go from a cube, 1 meter on each side, how many liters is that? Well, the volume of that cube in meters would be 1 meter times 1 meter times 1 meter, or 1 meter cubed, correct? So that's going to be what we're given, and we have to somehow convert that to liters. That's the goal. So since we're only given, now you may know another conversion between meters cubed and liters, and of course you can Google it. But what if, here's the test, and you have to show your work or something, and this is the only thing that you're given other than knowing the metric prefixes? Well, it looks to me like, so just in terms of the thought process, how do we get from meters cubed with, I don't know if it's 3 steps or 5 steps or what, to get to liters? Well, we know we can go from meters to centimeters, right? So just thinking this through in terms of the path, meters to centimeters, or meters cubed to centimeters cubed, and then to milliliters, and then to liters. Now, here's the deal. Of course, I've been, teaching chemistry for over 30 years, and I'm pretty well practiced on this. Although my old age now, I'm starting to lose it a little bit. My brain's not as good, so I'm more prone to mistakes, which is actually, it's going to make me a better teacher, right? Because I'm going to be more like a beginner. All right, I'm hopefully just joking, but anyway, so I have to try and put myself back into the beginner's shoes in order to do this, right? And think through how would we do this? How difficult would that be or not be? So and I know, when we're in class, I can see you, we can talk about it. I know for a lot of you, this is not going to be difficult. Remember what we talked about in the intro. Some people are starting on mile 0, some people are starting on mile 22. And so in doing this, we've got meters cubed, and we want to get to liters. You're not always maybe going to be able to see this path, right? And in solving, especially once we get into stoichiometry and chemical reactions and all that, don't worry about not knowing the whole path. Just take the first step, right? Take the first step. So meters cubed, and we know we can get from meters cubed to centimeters cubed. But we got to be careful with that, right? So there's 100 centimeters in 1 meter. But remember, meters cubed is actually meter times meter times meter. Okay, and so really to do this, we would have to do this 3 times, right? Because you're canceling out meters, 1, 2, 3, 1, 2, 3. Okay, now I'm pretty sure that most of you will see that we wouldn't, you know, if you need to, certainly do this, right? Write it out 3 times, make sure now we're in centimeters times centimeters times centimeters. But you can do 100 centimeters is the same as 1 meter. And notice I'm already, you know, we moved pretty fast in Gen Chem. We've got our conversion factor up here. And I just, oops, I didn't even write it down this time. So 100 centimeters is 1 meter. And I just put it down. So centimeters in the numerator, meters in the denominator, so that we can get the cancel. And, you know, after you've practiced some of the conversions in the book, you will hopefully get to that point too, where you can, but as long as you need to, you can write down all the conversion factors and then flip them whichever way you need to go. So this is actually then cubed, right? And that'll take care of the meters. And now we're in centimeters cubed. Then we would say, well, I want to get into liters. I don't have a way to get the liters, but I have a way to get the milliliters up there. So I'm going to write 1 milliliter is the same as 1 centimeter cubed. Now, how did I know to put milliliters on top? Well, I knew it because I wanted my answer to be, so I need that unit in the numerator, and I need centimeters cubed to cancel. But if you don't see it, it doesn't matter. Don't sweat it, right? If you put it down and you have it flipped, the units won't work, and you'll know that, oh, I need to flip my conversion factor the other way. It's no big deal. Then milliliters to liters, well, a milli is 10 to the minus 3, so we could use that as our definition. A millennium is 1,000 years, and so the way that I remember it is that there are 1,000 milliliters in 1 liter. And there's my conversion factor, and that cancels out. So now I've got 100, but that's 100 cubed, 100 times 100 times 100, which would be 10 to the 6th divided by 10 to the 3rd. So this better be 1,000 liters. And I really hope that's the right answer. All right, so 2 examples, one with, you know, multiple units. You can see that conversion. And I'll see you the next time. Thanks.